Okay, so today's question is minimum operations to make a uni-value grid. So you are given a 2D integer grid of size n cross n and an integer x. So in one operation you can add x or subtract x from any element in the grid. So a uni-value grid is a grid where all the elements of it are equal. So we have to make all the elements equal. And we have to return the minimum number of operations to make the grid uni-value, means all the values should be same, and if it is not possible, return minus. Okay, so let's take an example. Suppose there are two values, okay, a and b, and we want to make them equal to a value b. Okay, and in one step either we can add x or subtract x. Okay, so what can we do? Either it can be a minus x or a plus x. Okay, now for a particular value to be equal, okay, suppose so this a minus x or a plus x we can do. So what will be the difference between the final value and the real value? The final value, suppose it's v, then difference will be v minus a, and this v minus a will uh, always be divided by the x, as the difference created is the nothing but the multiplication of the difference value. So v minus a modulus x will always be equal to 0. What that means, v modulus a should be equal to v modulus x should be equal to v modulus x. Okay, so that means we can say that a particular grid can be uni-value if we divide each element by x and we get the same remainders in all. If the remainders are not same, that means this cannot be divided into this cannot be changed into uni-value, means all the values should be same. So let's try to code this. What we will do first, we will make this as a 1D array. Okay, so let's do that. Give it some name, r is equal to this. You can give n is equal to len of grade, n is equal to len of grade of 0. Yeah, and you can set answer as 0 at the starting. Now simply flatten this grid. So for I in range n, for j in range n, here are dot append grid of I j. Now what we have done, we have just created a 1D array. Now suppose we have given a value like 1 2 3 4 5 6 in this. So if the number is sorted, okay, if we will sort this 1D array, and suppose we are taking the target element to change all the elements to the target element as the last element. So if the target is the last element, then the smallest element will have the more steps to go towards that. And suppose if we take the smallest element as the target element, then the farther one or the largest one have to get subtracted that particular time. So it will take more number of operations. So what we will do, we will take the medium of that particular numbers. So if the number is in the between, it's the same distance from the smallest and the largest. So the number of operations to convert the smaller to that middle and largest to that middle will be less. So what we will do, we will sort this array. Okay, now take what's the length. So length of the array is nothing but n cross n. Okay, and what else, you can take the median. So let's give median of name as target. So median will be nothing but the middle element. Okay, so it will be ARR of length double divided by 2. Okay, it is the division. Now we have got the target. Now we will simply go through this ARR. Okay, and we will check every number. If the remainders are same, we will continue and add the how many number of operations needed to convert this thing into uni-value. So let's do that. So for I in, let's simply go ARR. So for I in ARR, if I modulus x is not equal to the final value, what is the final value? This time not equal to, sure, phi modulus x is not equal to target modulus x. Okay, so means this grid cannot be converted into uni-value grid, so we will simply return -1. Else, what we will do, we will simply append the answer. So answer plus is equal to absolute of what will be the final value? This target minus current I, and how many steps taken, that we can know simply dividing by x. So yeah, now finally we can simply return answer. I think this should work. Let's try to run and check. Yeah, so test cases has passed. Let's try to submit and check. Yeah, so our code has passed successfully. Thank you for watching.